Hello, my name is Bowen, and here I'm going to present my agentic homework. Well, there are really very long list of my project, so I choose the second one, the unbenching large language models for political science, a United Nations perspective. And here is the link to the papers and the link to the GitHub. Well, if you can just click on the paper, it will be shown like this. Luckily, I do not have to pay anything for reading the papers. So yeah, so it's basically give you a brief introduction of this project about, well, just let me say in one sentence. It asks the large language model to guess the correct co-author when implementing a specific United Nations worldwide task or say policies. Well, there are three different steps in creating a successful resolutions. The first one is drafting, like who is going to be the main drafter, who's going to be the pen holders, or they say co-authors of the resolutions. The second one is voting, whether the other member of United Nations going to agree with these resolutions and going to be discussing the futures. Say Chinese people negotiate with the tax rate with United States people. Well, it's very simple and very clear, straightforward. And here is the GitHub file. So basically, it only contains three different files. The first one is about the data. The second one is about figures. The third one is about notebook. I try to implement the notebook number ones. So it's basically notebook number one is the drafting part. So it asks large language model to guess who could be the most likely co-authors from a large context, say under the large language model do not know anything about the co-authors. Guess who's going to be the most likely co-authors from the draft. So yeah, I try to implement everything in the Google Colab. So let me explain the most main part of my presentation. The first one is a simple clone the GitHub and cd your root or give the permissions to Unibench and open the new file about Unibench and check whether everything is on the files. So yeah, it's completely aligned with the GitHub repository. And third one, the summary of Unibench. So it's giving me a brief introduction of what's the whole project about and what's my task one demo about. So if you can read lately, I read everything manually, so it could be very straightforward. And yeah, here is the implementation of the task one. Basically import your JSON files and open the task one JSON file from the repository. And I create different arrays. The first one is a draft ID. Second one is the temporary resolution of authors from the large language models. And the choice 2, 3, 4, 5 is about the difficulty levels, about the number of the options in the multiple choice. Well, forgive me not explain the 2, 3, 4, 5 scenarios. So basically, it's actually referred to the number of the potential candidates choice presented to the large language models. It's very common method to evaluate LLMs. And for example, the two choice one is very simple, just like A or B. So even if the model completely wrongs or say meaningless, it can still get 0.5. 1 divided 2 equal to 0.5. And the fifth choice one, the default baseline is very low. It's only like 0.2. So I try to focus on the 5 choice questions because it gives a lot of nonsense, a lot of meaningless choices and ask the LLM to guess the correct answer. So it's basically the most difficult ones. So here, the task one. Oh yeah, here is the API usage. I use the DeepSeek chat, and here is API key, and here is this cell is mainly about interactions with operating systems, especially locate different files under different locations. Yeah. Well, here is the main part. It's basically ask the assistant to define its positions and ask the user to ask something about the large language models. And here is the parameter settings, the tokens numbers, temperature numbers, and here is the noun check. If the result is not valid response, just give it away. And yeah, here is everything about the parameter explanations. I try to type it manually, so it should be very clear forward. For example, the result arrays, iterative processing loops, or prompt engineering consists of two prompts, system prompts and user prompts, and the API call using the DeepSeek and my models, DeepSeek Chat, and it's only focused on the deter deterministic output, so it's very straightforward. And here is the loop. Here is the loop. So you can see each subset consists of 13 different records, and it's only running for like minutes. So it's because of my set the token into 20, so it could be very fast. And here is the accuracy formula, and here is the final result. As you can see, for the two choice one is only 0.5. So, but for the five choices one is only like 1/3. So yeah. So what I changed for the modifications, I want to actually say increase the possibility of LM guessing correct answers into 0.5. So I try to change of different parameters. For the most one is the temperature one. I try to make it more fluid, and I change the p-values in 2.5 to enhance the decision-making quality. And here is the penalty part. I introduced two penalty, the frequency penalty and the presence penalties. It's all gonna explain in the PowerPoint, which I'm going to explain lately. And here is the final result. I successfully do the modifications and improve the accuracy into 0.5. So I actually try to adjust the different parameters into this one, and the result varies a lot from 0.2 to 0.1 to 0.3 to 0.4, and 0.5 could be the most high answers. So I set temperatures and the p-values into 0.5, 0.1 and 0.9 respectively. I also used to change the temperature into 0.5, 0.1, and the p-value into 0.9, 0.95, etc. And I think this combinations gives the most highest result. And yeah. And I did not increase the token numbers, so I think it should be running properly. And yeah, just let me explain my PowerPoint, final explanation of my project about. And like what I said, the brief summaries of project and setup, target, result, modifications, debug, and conclusions. Well, this project summary is the Unibench evaluate AI understanding of the global governance by simulating United Nations Security Council tasks, specifically focusing on geopolitical reasoning capabilities. And the goal is to find who's going to be the co-pen holder judgment. So task one, LLM must identify the correct co-author for a resolution draft from a list of 2 to 5 choices. Here's the environment. I use OpenAI and or Google Colab, and the computing infrastructure, Google Colab as well. Data sources, task one JSON source is all in the GitHub repositories, and the API configuration, I use the DeepSeek chat model. And here is reproduction target. The difficulty tiers varies from 2, 3, 4, 5 choices, and the LLM must guess from different number of the multiple choices questions. And the evaluation metric, basically how to guess the accuracy level. And here is the initial result from the task one. So the 2 choices only on the average, but the 3, 4, 5 choices multiple choice question actually perform above the average, especially for the 5 choices one. And I did the modification to increase the 5 choices one into up to half. So basically improve about 0.16, so almost half of the original answers. And I try to change its parameters from temperature ranging from 2 to 2.2. 2 to 0.2, yeah, and the optimal is 0.1 actually, and the p-values into 0.9, 0.5, 0.95, because it follows the normal distribution factor. And the penalty enforcement, I also use the frequency and presence penalties, and this combination gives the most right result. And the debug diary, well, this part is somehow confusing because the original modification I tried to use is chain of thought because it's asked LLM to read a whole bunch of very long text, and I think chain of thought could be very promising under very large volume of context. But because my technical capabilities, I did not perform very well. So yeah. And the final conclusions is that it's very easy to replicate it. I keep everything on the Google Colab. If you have the right environment, you can just run my Google Colab file. And yeah, for the future references, I can say I need to improve the two question scenario up to like 0.6 or 0.7 because the 3, 4, 5 scenario always perform above the average. I do think 2.2 need to perform the average. So I think the essence is to say keep everything simple. So if you can see here, my original answer, the original task one repository answers is very long. Like sometimes it also asks the AI large language model to read a whole bunch of very, very long drafts. It's about the draft materials. So I keep everything simple, but here I keep everything simple. Just give me a brief position of what's the AI and ask users to co-author the resolution draft, which actually very promising. Yeah, very promising. So I also can run other accuracies like 5 choices, 3 choices, 4 choice, 5 choices, one. But I think if you can concur with the 5 choices, multiple choice question ones, I do think others will also perform very well. So yeah, these two could be marked as future references. Yeah, here is all about my introductions about my project. I keep everything comments and I keep everything manually type here about the strings, about the Boolean type, oh no, the Boolean type data type. So it could be very straightforward here. Yes, thanks for listening. I hope I can get a good grade.